Okay, hi guys. So we'll be continuing on seeing the calculation of n factor for different compounds in which one of the atoms can go into oxidation and another can go into reduction. So let's take another note at the starting of this lecture that when partial oxidation or reduction of substance takes place in balanced redox reaction, we'll see the example of the same. Partial oxidation reduction of substance in balanced redox. So that would be K2Cr2O7 plus 14 moles of HCl gives 2 moles of KCl plus 2 moles of CrCl3 plus 3 moles of Cl2 plus 7 moles of H2O. So in this case, Cr is again going from plus 6 state to plus 3 state. Okay, and this implies the n factor of this compound is 6. So since the number of electrons which were gained in the reaction were 6 moles of electrons were gained in the reaction from so let's not write it. So total 6 moles of electrons were gained. So n factor for this compound is 6. N factor for this compound would be number of electrons gained divided by moles of this compound reacted, which would be 14. Similarly, these all can be calculated. Okay, so just writing it that 14 moles of HCl released 6 moles of electrons that were captured by chromium, and this implies that 1 mole of HCl released 6 by 14 moles of electron. Okay, so therefore n factor for HCl would be 6 over 14. Okay, now let us move on to another topic wherein we have to calculate n factor of reactant oblique product in balanced reaction so that would be simply writing as n factor which would be equal to moles of electron exchanged between reactants or moles of electrons involved in redox divided by stoichiometric coefficient of reactants or products in a reaction. So n factor would be equal to moles of electrons exchanged between reactants or moles of electrons involved in the redox divided by stoichiometric coefficient of reactants oblique products. In a reaction. Okay, just an example, we have K2Cr2O7 reacting with HCl producing We have seen this reaction. 2 moles of KCl reacting with 14 moles of HCl, forming 2 moles of KCl plus 2 moles of CrCl3 plus 2 moles of Cl2 plus 7 moles of H2O. So N factor here would be 6 upon number of moles of K2Cr2, which is 1. N factor here would be 6 upon 14, would be 6 upon 2, 6 upon 2 again, 6 upon 3 and 6 upon 7. Okay, so as number of moles of electrons participated in the reaction were 6, and similarly, since for various compounds involved in the reaction, N factor would be number of moles of electrons participated upon stoichiometric coefficient. Okay, in other words, we can also say that 6 equivalents of every substance is involved in redox. Okay, next let us say take another example. Which is this reaction KMnO4 plus K2Cr2O7 plus HCl forming MnCl2 plus CO2 plus KCl plus H2O2. Not H2O2, H2O simply. First we have to balance this reaction. So by trial and error you can try this as a homework exercise, and you should come up with this as the final balanced equation. 10 moles of CO2, 12 moles of KCl and 8 moles of H2O. And regarding the oxidation state, which is going from +7 to +2, and chromium going from so did I miss something in writing the Cr atom here? So let me recheck. I by mistake I wrote it wrongly. This is C2O4. I beg your pardon. So this is C2O4, not K2Cr2O7. This is C2O4 and this is CO2 gas. Okay. Now the oxidation state of Mn is changing from +7 to +2, and for carbon atom it is changing from +1 to +3 to +4. Okay, so N factor here would be, as there are only 1 mole of Mn present in the whole compound, so N factor would be 5, and here N factor would be 2. Okay, why? Because oxidation state of C is changing from +3 to +4, and in 1 mole of the compound 2 moles of carbon atoms are present, hence N factor is 2. Okay, and by the way, how many moles of electrons are involved in the reaction? Because I have to also calculate, or rather we have to also calculate the N factor of the remaining compounds as well. So total moles of electrons involved in the reaction would be, so we know that N factor equals to moles of electrons divided by stoichiometric coefficient. So number of moles electrons from this would be 10, or you can also take from 2 into 5, it would be 10, and 5 into 2, again it would be 10. So moles of electrons would be 10. So n factor here would be 10 by 16. For this it would be 10 by 2, again 10 by 10, then 10 by 12, and 10 by 8. Okay. So with this, let's jump to the next topic, which is calculation of n factor in decomposition reaction. Okay. So this is nothing but intramolecular redox. So first let us see KClO3 forming KCl plus oxygen, gas is released. So oxygen is going from -2 to 0, getting oxidized, and Cl is going from +5 to -1. So n factor in this case would be, so for calculation of the n factor, we can take either of the two. We can also take case 1 could be the reduction of Cl from 5 to -1. So number of electron gained by Cl would be 6 in case of reduction, and in case of oxidation we can say that 2 moles of electrons were actually released by oxygen atom during the course, and total 3 moles of oxygen are present in the compound, and 6 would be the n factor in case of oxidation. So either way you can calculate, answer would remain the same. So with this we come to the end of this lecture. In the next lecture we'll be seeing more on the n factor in decomposition reaction, and then we'll be moving on to see n factor in case of disproportionation reaction. So till then, good luck and goodbye.